Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. So let's look at question 3, which is the analytical geometry question for the November 2023 question paper. Good. So in the figure, okay, let me do this. In the figure, L, S, and N are the vertices of a triangle having SLN as is 90 degrees. LN intersect the x-axis at K. Okay, what's that? This angle, theta, it is the angle of inclination between SN or NS, natural science. Okay. Calculate the length of SL. The length of SL, guys, sometimes I feel like not doing this question. But if you do that well, you'll get that the length of SL, you'll see that the length of SL, it is something like square root of 80, square root of 80, or you can say 4 square root of 5. Guys, I don't want to make the videos long because it's tiring for the video to be long. But you know, the distance formula is that it's the same as doing it here. -4 minus 4 squared plus 1 minus 5 squared, and then you square root. It's just that. And then calculate the gradient of Sn. It's one of the questions I don't like doing. Gradient of Sn, gradient of Sn. Gradient of Sn is going to be -2 minus 4. I will start with the y. -3 minus 5. -2 minus 4. -8 divided by -6. It is the same as 4 divided by 3. So just that, guys. So the gradient of this line, 4 divided by 3. And then find the equation. Okay. Find the angle of, calculate the size of theta, the angle of inclination of Sn. So guys, we know that for the angle of inclination, we know that the gradient of Sn is equal to tan of the angle between it, which is theta. 4 divided by 3. It is equal to tan theta, and then theta is going to be arctan of 4 divided by 3. And then we get something like 53.13 degrees. I'm moving on. Determine the equation of the line passing through L and is parallel to Sn. Parallel to Sn. It is passing through L. It's parallel to Sn. So if this is Sn parallel to that one, it means that line should be something like, yeah. So it is parallel to Sn. And I know that if lines are parallel, their gradient are the same. So for me to find the equation of its line, it's easy because now I'm going to say the gradient of the parallel line. Sorry, the gradient of the parallel line. What am I looking for here then? Where am I? 3.1. Oh, sorry guys. Yeah, 3.4. Okay, before I go there, 3.4. Oh, sorry guys. 3.4. 3.4 says calculate the size of L and S. L and S. L and S. Where is S? There. Guys, I think everyone knows now what I like to do. If you are my subscriber, they're off. You know that LSN, it is this angle, they're off. So I like to find a triangle. Okay. Well, you think of doing this triangle, but I want you to see something. If you look at the triangle, they're off. If you check the triangle, you will need this angle, and it will take time to find that angle because it is an angle between two points. An angle between 2 points. Let me see. Let me do an imaginary there off. Continue. So it's going to be an angle between this one and that one. So What I'm gonna do instead, I'm gonna be using this triangle. This one, the smaller one, the off, this one. Okay, and then let me do this. If I do that, I can say, let me see. Let me try to extend this line. Is gonna be what? Okay, extend it here. Why? Because the angle of inclination between this one and this, like, can you see this one? If you do this is also theta. Why? Because vertical opposite angles. And then this, let's name this beta, and let's name this theta, and okay, not theta, alpha. And then when you use the sum of angles in a triangle, something like this, the angle here is going to be equal to this and this. So it means it means B is going to be equal to alpha plus theta the off. So it means my main goal is just to find the angle of inclination of Ln, okay, which is angle B. So I will need the gradient of Ln. I will need the gradient of Ln. Or is there another way I can find Ln? Oh, I can find Ln, guys, by saying, actually, let me see. I think I can find this angle. Oh, okay, it's easy, guys. Check. I have a right angle triangle here. Right angle triangle here. Let me remove this and say, okay, if this is a right angle triangle, and then this is my hypotenuse, and this is I'm looking for this angle, so this is going to be my opposite, and then this is going to be my adjacent. So it means for me to find this angle, it's going to be opposite over what? I have this length, guys. Remember, it is square root of 8. And then I can find this one, Ln. And then, yeah, let's find the Ln, length of Ln. Length of Ln, when I do that, do I find the length of Ln to be something like 2 square root of 5? I think it is easy for everyone to find the length of Ln, guys. It's easy to find the length of Ln. 1 minus 3, it is 4 squared, plus -4 minus this, it is plus 2, so it's going to be 2 squared. And then something like 16 plus this is square root of 20. Okay, let's just use square root of 20, maybe. Square root of 20, which is the same as 2 square root of 5. Also remember, this is the same as 2 square root of 4 square root of 5. So opposite over adjacent, it is tan. So tan alpha is going to be opposite, which is square root of 80, divided by square root of 20, which is adjacent. And then I just alpha you get to be something like alpha you get to be something like, you can use sine, guys, by using this side or what I'm using that one. Then it's going to be something like 63.44 degrees. So I almost went the long route, but yeah. Okay. So yeah, that's that, guys. Just right angle triangle. It was best for us, the off. And then yeah, we have found alpha, the off. And then what do they want us next? Oh, remember they talked about the parallel lines that I ignored first. I'm going to need something here. Let me only remove this. The question says, find the equation of the line parallel to Sn and passing through L. Okay, which passes through L and parallel to Sn. So that line, remember, I drew it something like, okay. So we know that this line, it is parallel to that line. And then for me to find the equation of that, it's easy, guys. How many marks? 3.5, 3 marks, guys. It's easy. Why? I already have the the gradient. Okay, I know the gradient of that line. Okay, I know the gradient of that line. I'm going to say the gradient of Sn is going to be equal to the gradient of the parallel line, which is equal to 4 divided by 3. Why? Because the parallel line is perpendicular to it's parallel to the Sn. So it means now for me to find the equation, I have a point here. I have a point there off, guys. So that point, I can say y minus y1, it is equal to m into x minus x1. Y minus y1, it is 1. M 4 divided by 3. X minus x1, it is plus 4 because it is minus 4. And then the equation is going to be 4 divided by 3x plus 16 divided by 3 plus 1, which is just basically 19. So this is the equation of the line, guys. Calculate the area of LSN. LSN. Area of LSN. Okay. Guys, it's easy. Remember, you have the side here, square root of 80. And then you have your base here to be, what is this? Uh, LSN. LSN. Calculate the area of LSN. LSN. Okay. So remember you found this to be square root of 20. And then the area says area is equal to base times height. Half times base times perpendicular height. Okay, so this line height, it is perpendicular. I can see by this again. And then it just simply me saying base square root of 20, height square root of 8. Guys, you can use both 2 square root of 5, 4 square root of 5, it's fine. Then it's going to be 0.5 multiplied by square root of 20 multiplied by square root of 80. I get 20. 20 units squared, guys. 20 units squared. Why? Because we already found the length for Ln here. You still remember? You still remember when we found the length of Ln? We found the length of Ln already in the question thereof. So yes. Then I move on. These questions are so beautiful. The examiner was genuine here. Calculate the coordinate of P, which is equidistant. You need to understand what exactly equidistant mean. What does equidistant mean? Where is that point? P. Let me remove all the mess. Sometimes we need a fresh sketch so that we understand exactly what we are doing. So let me erase this. Where is P? P, calculate the coordinates of P, which is equidistant from L, S, and N. L, S, and N. L, S, and N. Here you go. L, S, and N. L, S, and N. L, S, and N. So I need to find a point that is equidistant. A point that is equidistant. So for that point to be equidistant, I think it's supposed to be, remember, okay, the question is, what are equidistant, guys? Equidistant means it is somewhere in the middle. Okay, basically for something to be equidistant, the lengths are equal, like this length here, they are equidistant. Okay, so if I were to put P somewhere between the triangle, maybe let's say I put it here. P. It means now this length should be equal to that length, should be equal to that length. Does it make sense, guys? It does make sense. But now, if I check this one, I can say, okay. I can say, how about if I were to do this so that I analyze it geometrically? Okay, I got it. So if this is 90 degrees, guys, it means now a point anywhere thereof it can be. Okay, so it means, remember, if from geometry, a line that subtends, that creates a 90 degrees, it is the diameter. So if this is the diameter, guys, if this is the diameter, then P is supposed to be the what? The midpoint, okay, or the center. So P is the center. So if P is the center, therefore it means I need to say, okay, firstly, tell the examiner that uh, angle L, okay, angle L, it is equal to 90 degrees. It is given. Therefore, SL is a diameter to a circle of SLN. Okay, how do I know that? I can say converse angle in the semicircle. Geometry. Utility geometry. Converse angle in the semicircle. Okay, sharp. Then, how does it help me? Therefore, it means, therefore, P is the center. It therefore means P is the what? Is the center. P is the center. Okay. When P is the center, therefore, it means I can use midpoint. Therefore, I can use midpoint and say, oh, okay, P means it is now -2 plus 4 divided by 2, -3 plus 5 divided by 2, and then P has a coordinate of 1 and 1. How predictable am I? Can you see that, guys? So it's just that for 3 marks. Or you can say equidistance NP, let P become A and B. Okay. Let P become any coordinates X and Y. So you can say NP, it is equal to PN. Okay. And then if you do that, you'll see that NP, NP, the distance of NP is going to be okay, just do this. NP is equal to PN, equation 1, and then the second equation you can use LP is equal to what? LP it is equal to LP it is equal to, you can also use PN again. PL LP can equal be PS. I didn't. NP and PN are the same thing. PS, guys, this one, it is equal to this one. And you can say this one, okay, LP, it is equal to, you can use any other length. Any other length. It is equal to NP again. Equation 2, and then solve this simultaneously. Okay, yes, so that's that, guys. Last question, calculate the size of LPS. LPS. Okay. LPS. Okay, let's see how can you find the length, the angle LPS. Which one is that? LPS. This is the angle that they're referring to, LPS. How can I find that angle? Okay. Okay, guys, I'm gonna allow you to do this in using uh what is this? Using LPS, right? LP. Which angle do I have? LPS, yes. LPS. I'm going to allow you to use this. You have this side here, PS. Okay. Remember the coordinates here, it is 1 and 1. So find distance PS. Okay. When you find distance PS, I think you'll get something like 4 minus 1, it is 3. Then 3 squared, okay, this is going to be 5. And then the length of LP is going to be 5, since they're equidistant. And then the length of LS, have they given us that? SL. You still remember we found the length of SL here on the first question. SL, the length of SL to be something like, I think it was square root of 8. So yeah, we can use that and say this is square root of 8. So can you see if I were to isolate that triangle thereof, it will give me something like this. And then this is the angle I'm looking for, 5, 5, square root of 8. What comes to your mind? Cosine rule. Cosine rule again. So we can find cosine rule to find that angle. We can use cosine rule to find that angle. So cosine rule says it's going to be this side squared is equal to the adjacent side squared, which is 5 squared, plus 5 squared minus 2, the product of those adjacent side, cosine of the angle I'm looking for, L angle PS. Okay? And then when I do my mathematics there, you find that these ones, when they come to the other side, 80 minus, okay, plus here. 80 minus 50, it is 30. When I have 13 here, it is equal to negative 50 cosine of LPS. Cosine of L angle PS is going to be 30 divided by negative 50, which is basically 3 divided by 5. It's fine. And then LPS, when you take the inverse or a cos of negative 30 divided by 50, you get an answer something like 126.87 degrees. Cool. Done. Last one for analytical geometry. In the diagram, the circle with center O has a equation, that one. Okay, this one. You know, when you have an equation like this, you have a what? You have the coordinates at it passes through the center is at the origin, 0 and 0. And then G is the center of a larger circle. And then A is a common tangent. So a common tangent touches circle at D and F, okay, respectively, okay, such that D, P of negative 2 lie in the fourth quadrant. So we have the coordinates of D here to be equal to P and negative 2. Okay. Show that DP, okay, show that, so given that D of those coordinates lies on the smaller circle, show that P is equal to 4. Okay, it's easy. I have an equation of a smaller circle again. Equation of the smaller circle, so I can substitute because it lies on that smaller circle like that. I can say, therefore, let me substitute x as p squared plus y, it is negative 2 squared is equal to 20. And then p squared, it is equal to 20 minus 4, it is 16. And then p is equal to plus or minus 4. But since well, it is on the fourth quadrant, p is supposed to be 4. Okay, that wasn't fair. That was fair. E of those coordinates is the midpoint of DF. Where is DF? Oh, okay. I have coordinates of E, which is there. I now know this one is 4. This one has a coordinate of 6 and 2. And then they want me to find f. Coordinates of f, guys. Coordinates of f is easy. How did D move to E? And then the very same way D moved to E is going to be the same way E moved to F. So from D to E, the X, what happened? The X we minused from 4 to 6. It means the X we added 2. And then the Y, what happened? The Y from -2 to 2. It means the Y we added what? 4. So it basically means now we are going to use what? Translation. Okay. When I answer this, you're going to say from D to E, what happens is that the coordinates thereof, they happened to be like X, they added 2, and then Y they added how much? 4. So you'll say also from E to F, it means the same order will follow. It means now we now have what? E. It is what? Remember, this is just obituary points. So E, arbitrary points, not obituary. Arbitrary points. So any point fell. So from E to F, E has a coordinate of 6. So it's going to be 6 plus 2. And then E has a coordinate, Y coordinate of 2. I'm going to add 4. And then it's going to be, F is going to have a coordinate of 8 and 8 and what? 8 and 6. Okay. Or you can use that the coordinates here, it is 6 and it is the midpoint and it is made by 4 plus the X of this divided by 2. And then the Y, it is 2. It is made up by -2 plus Y divided by 2. And then this is 12 is equal to 4 plus X. X it is equal to 8. Y it is 4. -2 plus Y. Y it is equal to 6. The coordinates of F it is 6, 8, and 6. So 8 and 6. 8 and 6. 8 and 6, where they? Okay, F, 8 and 6. Okay. So let's move on. Let's move on. Calculate the value of T. You were here. Determine the equation of the common tangent df in the form of y is equal to mx plus c. df. Okay, it's easy, guys. I can find the gradient of df. Okay, it's easy because I can find the gradient of df. And then after finding the gradient of df, or whether it is df or de or whatever, it's going to be the same thing. Okay? So let's find the gradient of df. Gradient of df is going to be equal to, this is 6. I'm going to say 6 minus 2 divided by y, it is 8 minus 4, which is 8 divided by 4, it is 2. Okay? It is 2. And then I need any point on the graph. I'll use E. I'm going to say y minus y1, it is equal to m into x minus x1. I just need any point on that line. I'll just use E. E, it is y minus 2, it is equal to 2 into x minus 6. Therefore, y it is equal to 2x minus 12 plus 2 minus 10. So that's that, guys. Easy peasy. Or someone might find the gradient of this one. The gradient of OD it is equal to -half. And then therefore the gradient of DF is going to be negative of the reciprocal, which is 2. Okay, because they are perpendicular. Tan perpendicular to radius. But since we now have points, I opted to use the points. And then they say, for 3 marks, calculate the value of T. Guys, how can I find the value of T? Remember, I know the gradient of this one. And I know the gradient of this one and the gradient of this one are going to be equal to -1. Why? Because they are perpendicular. So I'm going to say, therefore, the gradient of FG, it is equal to negative reciprocal of FD. What is negative reciprocal of FD? If FD is equal to 2, negative reciprocal is going to be negative half. Y, FG, let me say DF is perpendicular to FG. Or you can say tan perpendicular to radius. And then if I have the gradient now, I can say, okay, let me use gradient formula because it's beautiful. I'm going to say gradient of FG, it is negative half. And then, actually, what is the gradient? How can you find gradient of FG? It's going to be y minus this one. Okay? Y minus 0. So it's going to be 0 minus 6. Or you can say 6 minus 0 is fine. And then t minus 8. It is equal to negative half. When I cross multiply, I say, okay, let t minus 8 multiply by 1, and then the negative 6 multiply with a negative 2. Okay? Negative 6 multiplied by negative 2 is going to be 12. And then t is equal to 4. Guys, I'm lying here. I'm lying. 20. So the value of t is 20. Okay? So the value of t is what? It is 20. Oh, what you can do, Wena? I don't know what you can do. You can try to find the equation of the bigger circle and then become a mathematician thereof. So if t is 20, it means this one it is. Okay. The 4.5, determine the equation of the larger circle in this format. It's nice. Why am I saying it's nice? Because this is the center. And I already know the coordinates of the center, and I know any point on the circumference. I get, guys. So check. Why am I saying this is beautiful? I have the coordinates of the center, which is x minus a, which is 20 squared, plus y. Do you agree that it's going to be y minus 0 squared, which is y squared? It is equal to r squared. How can I find r squared? Just take the coordinates of AF, or just take the coordinates of any point on the circumference. Here. So any point on the circumference, it is f. So I'll use f. I'll say x, it is how much? 8 minus 20 squared plus 6 squared is equal to r squared. And then you see that r squared, it is something like 180. So if r squared is 180, it means I can come back and say x minus 20 squared plus y squared is equal to 108. And then let me try to simplify. It's going to be x squared minus 40x plus 200, plus 100, sorry, plus y squared minus 180. They were not 180 degrees, guys, 180. Then, okay, it is equal to 0. They want it in a format of blah blah squared plus y squared. Okay, sharp. So it's gonna be x squared plus y squared minus 40x plus 220 is equal to 0. Fine, guys. So this is how they want it. You're gonna give them the way they want it. Okay. Let's erase this, guys. I said it is x squared plus y squared minus 40x plus 220. Okay. Let's now look at this question. This question is interesting, man. It says the smaller circle must be translated k units along the x-axis, guys. When you do what? When you translate something along the x-axis, the y does not change. What changes is just the x. Okay? What changes is just the what? The x. So they want what here? Basically. Also, let me repeat that. The small circle must be translated k units along the x-axis to touch the larger circle internally. Okay. Calculate the possible values of k. Okay, I'm gonna show you the values of k that are possible for this one. Let me do this. This is gonna be a very beautiful illustration. I know when I use these ones. Let me use a color. Okay, it's fine. Color blue. I need this circle. Okay, to touch my graph internally. So it touch my graphs. It can touch my graph internally here. Okay, but it can also touch my graph internally also where? Can I crop this? No, it's fine. I'll draw another one. So I'm drawing another one so that I show you where it can touch my graph internally again. There. There. These are the 2 points where my graph can touch. Remember, this is man. Okay. Remember the coordinates here are what? 20 and 0. So this is the beautiful question. The question is now, how can hmm, how can I translate? Let's talk about this one. Can you see this one? The first triangle, sorry, the first circle, it is this portion that touches there. So I want to see by how much should I take this one? Hmm? Should I take this one, this point here, and take it there? There, here. By how much? Also, also, by how much should I take this point from here to that point? That's clear, guys, right? So we'll need to find that one. But the question is, how can I find that? How can I find that? Well, there are numerous things that you can try to do. Ne? There are numerous things that you can try to do. If I were to find the radius of this one here and the radius of the bigger one here, do you agree that this one will be the same as the radius thereof of the smaller circle, and this one will be the radius of the bigger circle? So it means for me to find now this radius, the smaller radius, the first R1, the of which I know the distance, this distance here. Okay, let me explain it like this. Um, let me explain it like this now. Let me explain it like this. Um, let's find. I'm not sure. I'm thinking of using. I'm thinking of using. What is this? What is this? What is this? The bigger circle, and translate it such that it becomes this one. Let me see something. I can say, sorry, you can let y equal to 0 on this one. Okay, I'm thinking of something. I'm thinking of something. Now, we have this one. Okay, okay. Let me bring back that down. We have the equation of the smaller circle, and it has an equation of y. It is equal to x squared. Okay, it has an equation of x squared plus y squared, it is equal to 20. 20, ne? So I can say, okay, how about I find where exactly will this one touch the graph, the off? Where is the equation of this one touching the graph of that one? Okay, where are they touching? Where basically this equation is equal to the equation of what is this, of this one. Okay, let's do this. Let's do this. We know that at this point here, y it is equal to 0, right? So at this point here, y it is equal to 0. So I can say, okay, x squared plus 0 squared it is equal to 20. Let's assume like because they share the same x-intercept here. Can you see at this point they share the same x-intercept? So I'll say, okay, let me find the x-intercept using this one. So it will be just x squared is equal to 20, which is x is equal to, when I take a square root of 20, I get 2 square root of 5. Okay? But also to a bigger circle, it is a what? It is a radius. But now what is the equation of the bigger circle? The equation of the bigger circle we just found to be, where is it? X squared plus y squared minus 40x plus 220. So for x-intercept on that graph also, for x-intercept on the bigger graph, we'll just say, we know the equation, it is x squared plus y squared minus 40x plus 220. It is equal to 0. And I want for y-intercept. For x-intercept, I let y equal to 0. So it's going to be x squared minus 40x plus 220. It is equal to 0. Ne? It is equal to 0. So anything that I can do, I can say, okay, I'm not sure whether to equate that. Oh, I'm thinking of equating the, let me see, the x squared. Yeah, let's do this. When you equate the x squared, it's going to be 40x plus okay. Okay, let's just solve the x-intercept for this one. Okay, the x-intercept for this one gonna be the first one gonna be x, it is equal to, use the quadratic here. Quadratic. It's gonna be x, it is equal to, I get your 20 plus 6 square root of 5. Okay, 20 plus square root of 5, and then and then uh 20 plus, or x it is equal to, I get 20 minus 6 square root of 5. Okay, guys, let me do this. Actually, let me erase this so that you understand what I'm gonna do here. If this coordinate here, it is, can you see this one is gonna be 20, this one here, gonna be 20 minus 6 root 5. And then this one here is gonna be the one that is 20 plus 6 root 5. And then we just said the distance, the x-intercept for the bigger graph actually. So the smaller graph has an x-intercept at 2 root 5. From here it is positive 2 root 5. So it means this one here, it is 2 root 5. And then this one here, it is negative 2 root 5. Because it is still the same x-intercept. Actually, remember when you square something, it is plus or minus. So this one will be negative 2 square root of 5. So now you still remember the question I asked you. How can I take this point here such that it comes here? such that it comes here. What is the distance between this one and this distance here? Okay, so the first distance that I might come across is that, okay, it's going to be k. This is the first one. K can be 20 minus 6 root 5. Yes, let me say 20 minus, okay, 6 root 5 minus what? Minus 2 root 5. So it's 20, this one minus that one. So that is the distance that it should be shifted for this one to be there, okay? And then we get something like 20 minus 4 root 5, which is just the same as 28.94. But this is not the only option, the only possible option. The other option is that I can take my circle and bring it here. It also touches once again internally. Again, we want the condition to touch the larger circle internal, and it can only touch once. So it means the distance from this one to this one there. Why am I saying there? Because, guys, you see that this point there, this point here, it is which one? It is this one, again, guys. So hence I'm saying the distance between there to there. So it is also another k. So for this one, I'll say k, it is what? This one, it is 20 plus 6 root 5 minus what? Minus this one, the distance, the x-intercept there, it is 2 root 5. And then, sorry, I get something like, why are the answers the same? This was plus, oh, this was plus, so it is 20, okay, or this one is plus, so this one is going to be 20 plus 4 root 5, which is basically 11.06. So these are the values of k such that we need to translate this a smaller circle by, so that it becomes the what? It touches the circle internal. So I need to translate the first one, this one. Actually, I need to translate this whereby 28.94. If I do that, it's going to end up here. But if I, okay. Which one is this country? Why are the values lying like this? Yeah, but yeah, either way, the values of this and this are that, guys. Are those. So yeah. So yeah, hopefully it's clear. What's important was finding the x-intercept, and then sketching and seeing the distance between the off. Makes sense that this part minus this part will be the distance, and then this part, okay, actually this part minus this part will be the what? The distance. Okay. Yes. So yeah, that's basically that. And thank you very much, guys, for joining me on this video day off. Okay. Yeah. Hopefully you enjoyed it. And let's go and have fun on trigonometry questions.